one of our rockstar MVPs, Marco Russo, who actually was the very first person I ever contacted once I joined the team. I don't know if you knew that or not, because he actually writes books that helps you translate in your head T-SQL to DAX, and that was exactly the place. I didn't know who Marco was back then, but I found his website, and I was able to go, if this is what I want to do in T-SQL, this is how you do it in DAX. So Marco, I don't know that I've told you this since then, but you actually really helped me out in the first couple of days of joining the team. So thank you very much.
You're welcome. I didn't know the story, so thanks
Yeah.
for sharing it. And welcome everybody. Today we're gonna see how to understand where is a problem when your Power BI report is low. So the idea, the goal of this session today is not to explain everything, because of course we cannot solve every problem, but at least giving you an idea about where to start, where to find if you have a problem in the number of visuals you have in a report, in some DAX formula, in some other connection. So this is the goal of the session. So getting an idea about what is going on and where we have to start. My name is Marco Russo. I wrote several books about DAX, Power BI, analysis services, and Power Pivot. For a living, I teach courses and do consulting, and you can find on sqlbi.com many information, documentation, free tools for DAX and Power BI. Agenda for today, we will see a few tools that are very useful. Task Manager that you have in Windows, DAX Studio and Vertipack Analyzer, which are free tools that you can download. I will show you the link later. And we will understand a few techniques to understand what's going on, how to isolate a potential issue in a Power BI report, and we will also see how to fix a query, even though I know that there are many details that we could add, but of course, it's not something that we can physically do in a single webinar. So let's start with a first tool that we may want to use. But before that, let's start with a problem. So I want to show you one report where we have a problem. Now, I just included an empty page. I will explain you in a minute why. But the idea is that this sales page, when I will click on this sales button, you will see a report appearing, and you will see many visuals. One of them is particularly slow to appear. So here we go. I click on the page. You see that all the slicer requires 1 to 2 seconds to be populated, but the one here at the bottom require more time. So do you see this list with the number of customers for each product require more time. So let's say that we have a problem, and as you see, this is also a Power BI file that you can download from this link. But I think I will provide you the link also at the end of the session. I will check with Charles how to provide you this link. But the idea is that, okay, there is something here that is not going well. So what can I do? And there are many things that we can do. But first of all, we should understand if the report by itself has a problem. Let me explain you why. So if I get a tool like the Task Manager, if you press Ctrl-Alt-Cancel, or you just go in the ribbon of in the taskbar of your computer, this is what you obtain by default. The Task Manager is something like this. I just enlarge this font with a zoom. You see that the Task Manager by default shows a list of applications that are running now. And if I click on more details here, I can see a bigger list of processes. And for Power BI Desktop, if I enlarge this, I can see that Power BI Desktop in reality is running a number of Windows processes. Why this could be important? Because you see that my Power BI Desktop now is consuming almost 1 GB. But how much of this size is actually caused by the data that I have? How much by the report, by the number of visuals? As you see, there are different processes that can be responsible of a certain consume of memory. And for example, you can see here that I see a process that is called Microsoft SQL Server Analysis Services, which is not necessary, is not my SQL Server Analysis Services that I installed. when you run Power BI Desktop always run a local instance of analysis services that has been installed when you installed the Power BI Desktop. And in fact, this process is running with my own user credential. I can show you this here. This machine has a lot of other processes running. And for example, the process that is running analysis services is this process, msmdsrv.exe. And you see that this process is running with my username. Whereas other processes that have the same name are running with a blank username, which means that they are running as a system services. Now, I won't want to go too much in detail, but the idea is that when you look at this detail of Power BI Desktop, you can understand how much memory has been consumed by my data, the tables, the relationships that I have, and also the calculations that I run. How much size is consumed by just the file that I open, so my Power BI Desktop, and how much size is consumed by the report that we are rendering. You see these four processes, browser, sub-process that you see, are basically a sort of internal browsers that are running and that are responsible of the rendering. Because when you run Power BI Desktop, it's like you have an iframe, a small browser that is running within Power BI Desktop, which is rendering the same content that you will see in your web browser when you go to powerbi.com. And you see that this amount is produced by just the display of the visuals. You might observe that when you open a big model, these numbers are much bigger. And finally, this Microsoft Mashup Evaluation Container is big when you have to load a lot of data, and Power Query, the M transformation that you have, load many data. So now, if we want to understand what is increasing the size of the memory when we open the report, what is the right thing to do? So let me go back here. First of all, now everything happens. So a good idea is to start with an empty page here, save the file this way, close everything, and open the file again. Because this way, now I'm opening the file from my from my computer. So you see that Power BI Desktop now is opening. The file that will, the page that will be open at the beginning is just the page that contains an empty page. And here we go. I can move this to the right window. You see that there are no visuals displayed now. If I go to the Task Manager now, I will see that Power BI Desktop is consuming a certain amount of data here for analysis services, but not too much. You see that I have a certain amount for the several browsers or processes, and you see that the total now is 526 megabytes. You see, this is the number now. So now I go to my Sales button, and when I'm loading these files, if I look at the Task Manager, you see that the numbers increased a lot. And I see that the number increased here in Microsoft SQL Server Analysis Services, and also in these browser source process. Why I'm showing you this? In this particular example, I increased the consumption of around 100 megabytes just for one page of visuals. But if you use custom visuals, each custom visual can consume much more. So for example, if I created the same page using many small custom visuals, the consumption in memory could be almost 1 gigabyte. I don't have an example now, but if you want to analyze, not that you know where you have to look at, you can analyze whether each page is consuming too much memory for your computer. Now we can focus on this SQL Server Analysis Services and on the problem that I'm facing. For some reason, when I run the query, the consumption of analysis services grown around 300 megabytes, and also I have seen this particular part of the report that was slower. And you can see that if I now check on one of the continents, for example, Asia, you see that all the visuals have been displayed in less than 1 second, but this one required almost 2 seconds. So now I want to analyze this. So what can I do? As I said, we have to introduce another tool that is called DAX Studio. And DAX Studio is a tool that I'm opening now. And this tool is able to connect to Power BI Desktop. You have to open Power BI Desktop before. And once you connect to Power BI Desktop, this tool is designed to create queries, navigate into the data model. You can see here I have a list of the tables, a list of the measures here. You can see many information, also a preview of the data that you have in each column. For example, here in country region, I can see a few, the content of a sample of 10 values for each column, which is useful when you create a query. I could use this as an editor to create the queries, but today what I want to use is this button, All Queries, which allow me to capture what's going on in Power BI. Because whenever I have a page in Power BI, that page has many visuals, and each visual generates at least one DAX query. I want to understand which one is lower. So I go back here. As you see, I click on Europe, for example. And when I click on Europe, because I clicked on a slicer that has a different value than before, you see that I have a number of queries that have been generated. Most of them have a duration. Let me highlight this. The duration is a duration in milliseconds. So each visual generated a query that has an execution time around 10 milliseconds usually, but this one required much more. So now what I can do, I can double click this query and I can show you exactly the query that required a lot of time. However, if I now click on North America, you see that I am generating other queries. In fact, if I go back to DAX Studio, you see that the other queries have been added here, and now this one of 2 seconds. I'm scrolling down. You see that this was the original query I highlighted before. Look also the execution time, 6:10:30, and now 6:11:13, because we spent 1 minute since the last click. But now, if I click further on this slicer, you see that everything is fast. Why? Because only the first time that I execute a combination of filters, I actually execute DAX queries. Otherwise, Power BI has its own cache, which is used to improve the performance of the visual. So what we are going to do, I will repeat what I did, because I'm interested in the very first query that was much slower than the ones that I executed now, especially for the list of products and customers. Why? Because when I didn't have any filter by continent, the execution time required to scan more data, and this was causing a slower execution time. So now I'm gonna close. Oh, wait a second. If you use this, before closing, you should create an empty page or select an empty page. To create an empty page, just click on New Page. Once you have this new page, you can save the file. I save, and I close the file. Why am I doing this? Because now when I open the file, the empty page that I just created will be the default page selected. And this means that no queries are sent to analysis services, to the engine of Power BI. This way, I have time to open my DAX Studio again. Now, DAX Studio lost the connection with the previous Power BI instance of Power BI, with the previous instance of Power BI Desktop. So now I click Connect again. I choose my Power BI file. In case I have more Power BI files open, I will see a longer list here, and I connect. At this point, I enable the All Queries button again, and I clear the queries that I executed before, because I want to make sure that I only filter the queries, the slowest query. I also clear this area, and now I switch to Saves. Let me go back to DAX Studio. In the meantime, you will see that when the execution happens, all the queries are displayed here. And as you see, the execution time of most of the queries was fast and quick enough. And I still have one of these queries that is the slowest one, this one. So at this point, I can continue to keep a Power BI desktop open, but I want to understand what is causing my slowness. So I double click this query, and if you want, you can also format the query with this button that calls the service that creates a query formatted according to the DAX format rules. And now I can look around here to find what could be the slowest part of the responsible of the slowness of the calculation. Now, if you know the data model, probably you know when you are referencing a column or a measure, and I can tell you that this customers is probably the measure that is responsible. So let me find customers here, and actually customers is a measure. You see that when you see this, this symbol, this is a measure. If I want to see here what is the definition of this measure, I can just right click and define measure. So I can see the measure here. Again, I can format the query, and I can see that this definition of sales customers is local to this query. Why this could be useful? Because once you have everything here, you can go in this area, traces, you can disable all queries, and you can start analyzing the query plan and the server timings. By doing this, I will be able to get particular numbers about these queries. I can already do this just to take a look. So I can go here, and I suggested to always clear the cache and then run, because also analysis services has an internal cache, and we want to execute the query in the worst condition when we want to understand what could be a performance issue. And once I do that, I am executing the query, populating these two areas here, query plan and server timings. As you see, server timings report the internal execution that is divided by formula engine and storage engine. These are two internal areas of the engine of DAX. And I already see there is something strange here. I mean, this query required almost 2 seconds in this second execution. And the query plan shows me all the details about what has been executed internally to solve this query. Now, you see that we have many rows. And actually, we have to analyze almost 476 rows. So sometime analyzing the data using the formula engine here, the query plan is not exactly easy. So I want to suggest you a better and easier way to just start. But let's say that once we isolated the slowest query of the report and the measures that is responsible for that, because in this case it was easy, we had only customers, which was the measure, and all the other elements were just columns, and you cannot have a report that is low because there is a column referenced here. Usually there is a measure or an aggregation over a measure that is low. Now we have to understand how to optimize it. However, before moving forward, I want to do a very quick recap of what we have seen so far, because we introduced DAX Studio, and DAX Studio is a tool that you can download from this link. It's a free tool, a free add-in for Excel if you have Excel, but also is a standalone application when you use it with Power BI. And it can be used to design DAX queries. It's an open source project, so the entire source code is available, and you can also participate to the development team. If you know C#, this tool is written entirely in C#. So DAX Studio has a query editor that is also integrated with the DAX formatter service and shows information about the query plan and the server timings. Now, in order to understand, however, what are the results of this query, one important thing to do is also to be aware of what we have in our model. And in order to do that, we have to, sorry, I'm just recapping here. We have to use another tool, which is Vertipack Analyzer. I was just reviewing the slides to make sure that I already presented everything I wanted to show you so far. This is just a recap of the steps that we executed to isolate the slowest query using DAX Studio. And we had to activate the trace, the all queries traces in DAX Studio, starting from an empty page. But once we do this and we collect a few information from the analytical elements of each individual query, we have to compare this with actually the size and the cardinality of tables and columns.
Hey, Marco, before you go on, Thomas asks a question that would be great to answer on your last slide. Even though Dan English already answered it, I want to make sure it gets in the video itself. So can DAX Studio connect to Azure Analysis Services?
DAX Studio can connect to Azure Analysis Services. Yes, you just needed to have the right drivers, but it's definitely possible. You have to be an administrator of Azure Analysis Services, so you cannot connect with a simple user, and the same is true for analysis services. When you use Power BI Desktop, you are an administrator of your local instance of analysis services used by Power BI Desktop. For analysis services on a server or analysis services on Azure, the only requirement, you have to be an administrator of analysis services.
Perfect. Thank you very much.
You're welcome. So, as I said, we have to know what we have in our model. And another tool that I want to use is Vertipack Analyzer. Vertipack Analyzer is a tool that you can download that actually is just an Excel file that you see here. This Excel file is built with a Power Pivot data model, and this Power Pivot data model reads data from analysis services or Power BI Desktop. Basically, behind the cover, we read the metadata describing the list of the tables, the list of the columns, the list of the relationships, the measures itself that we have in the model. And so the model here of Power Pivot is just a list of data collected from data management view from analysis services. And to be honest, you don't need to see this detail or to know everything about this. The only thing that you have to do, you want to refresh this model with the data coming from your Power BI Desktop. And the way to do that is to go in these existing connections and change the connection to the right connection to analysis services. You will see these steps described also in an article available in the link that I provided you. And what is important, you have to provide this string. Wait a minute, how can I know what is this number that I see here? Well, DAX Studio provides me exactly this information. So the reason why I started with DAX Studio is that in the right bottom corner here, we have the server name that is different every time you connect it to a different instance of Power BI Desktop. Basically, Power BI Desktop is always localhost, column, and a number. This number is a TCP/IP port number that changes every time you run Power BI Desktop. So every time you run the same file, this number is different. Now, in this moment, for this file is 31813. So 31813, let me write it here, 31813. You see that I specify this number here, and I have to read what is the name of the database for this port. Is a strange number. Is different every time you create a new Power BI Desktop file. And then I click OK. Once I do this and I save, I close this window, I go back to Excel, and you see that there is in the ribbon a button for Vertipack Analyzer, and you click refresh. Now, what is happening? The model that I have in Vertipack Analyzer is refreshed with the tables that I used in my Power BI Desktop model. And so I can see that my entire model is spending how much memory? Just 2 megabytes. So instead of consuming just 2 megabytes, I consumed almost 100 to 100 megabytes at runtime. So there was something that was consuming a lot of memory at query time. You can also have here a number of useful information. For example, if I open up table, I can see where I'm spending most of my memory. And you will easily find in a model that you never analyzed, that you will easily find a few columns that are very expensive, and maybe these are columns that you never use. So why not just remove them if you don't use them? So beside this very useful information, you have a number of other information that are, for example, a list of all the measures that you have in the model, a list of all the calculated columns and all the calculated tables. In this particular case, the only calculated table is the auto date and time table that could be created with a calculated table by Power BI. But for the basic needs that we need now, the only information that I wanted to see are how many rows I have in each table and how many unique values I have in the column that I used in my customers table. If you remember, my customers measure is basically a distinct count of customer key. And I see that I have 2,000 customers possible, and I have also 1,400 values in date. why am I highlighting these two informations? Because if I go back to the definition of my measure, you see that I have basically a distinct count over sales customer key, and I have a filter over sales where sales quantity is greater than 0. So I'm iterating the sales table here. I'm getting a distinct count from customer key. So if I go back to my server timings here, I should be able to figure out that, well, I have 17,000 rows returned by this query that is producing a list of product names and sales quantities. So basically, I have the unique number of product names and quantity, and I have a number of distinct count queries that have been executed for how many times? Once for each product. So what I'm figuring out is that because the result sent from the DAX query to Power BI is a list of products and number of unique customers for each product, I can understand without having a particular knowledge about the query plan and how all the details of this is the internal request made from the formula engine to the storage engine in Power BI Desktop and in the engine of analysis services. But without knowing all the details of how this works, I can figure out, wait a minute, for some reason, my query was generating an internal storage engine query for each product. As you see, there is just a distinct count of customer key, and in the where part, there is a list of condition that basically is filtering just one product name that I'm displaying in the report, in the result. And now here, I use my knowledge about DAX, and I know that, oh, look, I'm using calculate, using a filter over a table, which is a bad idea, because luckily, the engine didn't filter the entire sales table. If I take a look at the sales table is 10,000 rows, and we have 2,500 products. So in fact, we didn't have 10,000 storage engine queries. We had a smaller number of queries, 459, because probably there are products that have no sales at all. But basically, this query was particularly slow. And I know that in a calculate statement, what I should do is a column filter, not a table filter. A table filter is always a bad idea in calculate, especially if you have distinct count, but also when you have a sum or another aggregation. So if I retest now my query and I click run, I can see that my query now executes in just a few milliseconds. Look at this. In 16 milliseconds, my query produces exactly the same result. And now I have a single distinct count here for customer key, which is producing, sorry, this one. Product name and customer key is the query that is producing the result for each product. And there's another query for the grand total. So basically, with the minimum number of storage engine queries, I obtain the same result. So once I obtain the faster query, what I can do, I can go back, I can copy this measure. Because basically, I changed the local measure here. I can go here in selecting the customers measure here, and I can replace the code of customers with my new optimized version of customers. When I click OK, here we go. Now, when I click on a continent here, you see that every part is updated in a millisecond, in 20 milliseconds, and I no longer wait time. And even if I save, even though I save this, let me save with optimized. So temp optimized. So I have this version. Oops, not C, but K. Now I close this file, and I open the file again. So when I will open this file, you will see that the result will immediately appear in the dashboard, and I will not have to wait too many seconds as in the previous version. So let me wait a few seconds. You see that the query, I just moved this immediately. You see that this table appeared almost instantaneously, and even before a few other visuals this time. And even though if I select and select this, any selection is immediate, even though I just opened my Power BI desktop file. So let let me recap what we have seen so far. So we use the Vertipack analyzer to get better knowledge about our data model. And basically what I did is I tried to isolate a problem in DAX Studio, finding the slowest query. Then within the slowest query, I tried to isolate the measures that were involved there. And then I tried to analyze this behavior of the measure using DAX Studio, executing the same query several times, making changes to the DAX measure until I found better execution time. At that point, once I had the good execution time, I copied the code from DAX Studio back to Power BI Desktop. Why I executed this query in DAX Studio? Because it's faster to change something and reproduce the problem without having to wait the entire cycle of closing and opening Power BI Desktop again every time you want to do a test. And also to get the numbers that are, numbers at the millisecond, not just something. When you measure manually, you measure around the seconds. Okay, so I just have a few other links to provide, but I don't know if you have some question before we recap with the links.
There actually isn't a whole lot of questions. Fidzani was going and saying that is a huge improvement, but no, we're going along pretty good as far as not a lot of questions. You've done a great job of explaining it.
So is there some other question or?
No questions whatsoever.
Okay, so
they were asking about the slides.
I will provide
the link. Yes, exactly right.
Okay, so let me just provide a few other links because what to do next? I mean, I certainly shown you how to start, but what if you want to understand better all the numbers that I shown you quickly, the query plan and the server timings numbers? So certainly we have a lot of content. We have 4 or 5 chapters in the definitive guide to DAX book. Has a few chapters dedicated to optimization. We also have 2 white papers freely available on sqlbi.com. You can just follow the link and download them. And these white papers are dedicated on explaining the query plans in DAX using different techniques. And the tools that we have seen are DAX Studio and Vertipack Analyzer. Again, these are free tools, open source. You can contribute if you want. And I hope that soon we will have a version 2.0 of Vertipack Analyzer, but I think we are still a few months away, so we're working on it. Okay, Charles.
Let me unmute myself. That is great. Thank you very, very much for that. And so if you guys want to know more about this, obviously we're going to have Marco back for another webinar. He's a regular fixture here. Also, his partner Alberto is coming into town July 22nd for the Microsoft Business Application Summit. So he's doing a 3-hour deep dive, I believe, and he's actually doing a lecture and a theater session that we've got him booked for. So he's going to be in town, and you are going to be in Australia during that time. So we're going to miss you. And then
maybe there is someone in Australia that can watch some course or some. I have several user group meetings there in Brisbane, Brisbane, Perth, Melbourne. I still have to check for Sydney, but probably we'll do there something too.
And the other one that is that I would recommend while you guys are in town is Jeffrey Wang's. One of your old friends is going to be pairing up with Phil Seamark, who just released his book on practical DAX. So they're also going to be doing a deep dive into this topic. So anyways, Philip Andre says, great, thanks a lot. Greg Sharo says, excellent information. Eric Hyland says, thanks guys, really appreciate it. And Filippo Basili says, thanks very much. So no questions, but lots and lots of kudos. So for the 200 plus people that were on the call, thank you very much. Marco, I really appreciate it. And we're gonna have to actually get you back on after I get back from the Maldives and after the summit and after you get back from Australia.
Of course, of course. See you later.
All right.
Bye.
Thank you very much, guys.
Bye-bye.
Thank you.